Hi guys, our video today is a continuation of our notes from yesterday. So this is note set 7 and we're just continuing working on those. So I'm looking at example number 6. So last Friday and Monday we discovered a pattern for finding the sum of an arithmetic series. So this problem says find the missing value. We're given the first term is -10, the second term is 2, and we're trying to find the sum of the first 22 terms. So first I'm just going to kind of write down what I need to find the sum of the first 22 terms. And by the way, you can write that as a subscript or S sub 22. It makes no difference there. So I do know that I'm looking for 22 terms. And I'm going to divide that by 2 because that means there's 11 pairs in that sum. I need to find what those pairs add to. So I do know A1 is -10. What I do not know is the value of that 22nd term. So that's what I need to find. I can take the information I have here, though, and use that information to find the 22nd term. So I'm given the first term is -10. The second term is 2. I can use that to find the common difference. So 2 minus -10, 2 minus 1, so that's 12. I can then write the explicit formula, which is the same as point slope. And then if I want to find the 22nd term, I simply plug 22 in. I'm almost out of room. I should have written down here. So A sub 22 will equal -10 plus 12 times 21. And so I end up getting 242. So A sub 22 is 242. Based off that information, I can now find the sum of the first 22nd terms. 22 over 2 is 11. A1 plus I now know the value of A sub 22. And then I know 11 plus 232. So 11 times 232 is 2,552. Oops. Okay, let's take a look at what I know next. I need to find the common difference. So some things I know. I know the sum, I actually know the value of the sum of the first 21 terms. So let's think about that. I know the value of the sum. I know that there are 21 terms, so here's how I found the number of pairs. I need to find the sum of those pairs is 7/2. Oh, here's what I don't know. I don't know the 21st term. However, can I find the 21st term? Well, yeah, I can do that pretty quickly now. So I'm going to multiply both sides by 2, so I'm not dealing with that fraction. I'm going to divide by 21. I can take 14 and subtract 7/2 from that, and so when I do, and let me just remind you, by the way, if you're dealing with fractions, 14 over 1 minus 7 over 2, I do need a common denominator, so that'll become 28 over 2 minus 7 over 2. So I get 21 over 2. So my 21st term is 21 over 2. Do I now have enough information to find a common difference? Well, I have an ordered pair, and I have another ordered pair. And so as a reminder to you, those ordered pairs allow me to find the common difference, which is also called the slope. And so that's what I'm now looking at. The common difference will be found by taking 21 over 2 minus 7 over 2 divided by 21 minus 1. So 21 over 2 minus 7 over 2 is 14 over 2. Of course, what's 14 over 2? It's 7. So our common difference is 7 over, whoops, you can't see it, sorry, 7 over 20. All right, so let's look at our last problem here. So once again, we know the value of the sum is 300. I do not know how many terms there are. That's my goal. I do know A1. I don't know A sub n. Okay. Right now, I have two unknowns. And if I have two unknowns, I will have to have another equation. And so I'm going to kind of come to the side here. So let's see. I need to find an equation for A sub n. And I have enough information to do that. I have a point, and I have the common difference. So A sub n plus 10/3 will equal that common difference times n minus 1. So A sub n will equal negative 10/3. I'm going to go ahead and distribute, plus 2/3 n minus 2/3. Combine like terms, so 2/3 n minus 12/3, and negative 12/3 is negative 4. I now can plug this in every time I see A sub n. All right, I now have one variable, so now I need to go about solving this equation. I really don't want to work with fractions, so I'm going to multiply both sides by 2. So 300 times 2 gives me 600. N times, I need to combine some like terms here, so negative 10/3 minus 4, you can get a common denominator there, is negative 22/3 plus 2/3 n. I'm going to go ahead and distribute the n, so 600 equals negative 22/3 n plus 2/3 n squared. Again, I don't like dealing with fractions, so I'm going to multiply everything by 3. So 600 times 3 is 1,800. Negative 22n plus 2n squared. So as I look at this, I see that I have a quadratic equation. To solve that quadratic equation, I can factor, use the quadratic formula. So this is going back and reviewing some things that you already know how to do. So you got to reach back in that cobweb of your memory. One thing that does make your life much easier is notice that all of these are divisible by 2. So I'm going to go ahead and take 1,800 and divide it by 2. So I get 900, just lower numbers to work with. Negative 11n, and then n squared. Now to use quadratic formula, I'm going to set everything equal to 0, so I'm going to get everything on one side. I like keeping the n squared term positive. So quadratic formula, and how do I know quadratic formula? Well, my variable is squared. This is a quadratic equation. So now I now know n will equal negative b plus or minus the square root of b squared, that's 121, minus 4 times a is 1, times c, all over 2 times 1. By the way, make sure you set it equal to your variable. This just isn't floating around. It is what n will be equivalent to. So 11 plus or minus the square root of 121 plus 3,600 over 2. 11 plus or minus the square root of 3,721 over 2. I am going to go ahead and grab my calculator. 11 plus or minus 61 over 2. And again, quadratics typically have 2 solutions. So 11 plus 61 is 72 over 2, and 72 over 2 is 36. So that's a value for n that I've gotten out. 11 minus 62 is negative 50. Divide that by 2 is negative 25. Here's the thing. Think about where you're finding n. N is a number of terms. We cannot have negative 25 terms. So this answer does not apply. So therefore, it takes 36 terms of this sequence to have a sum of 147. So the answer there is 36.